So I'd like to talk today about the process of money supply creation and the money multiplier from an intuitive perspective by looking at bank balance sheets, much as Mankiw does in chapter 4. We'll follow Mankiw's treatment, in fact, exactly. So a bank has a balance sheet, and on this balance sheet the bank has assets and liabilities. And if we ignore the bank's capital itself, and we just think of it as an entity that receives deposits and makes loans, when the bank gets a loan, when the bank is open for business, somebody comes in and deposits $1,000, that is a liability for the bank and an asset for the bank. So the bank has the $1,000 that you gave it, but it owes you $1,000, so the assets and liability side are in balance. Now, what does the bank do? How does the bank make money? Why would anybody set up a bank? Well, a bank is going to take some of these $1,000 that it has, and it's going to make loans. And when the bank makes loans, it has to keep some fraction of the loans as reserves in the account. And so it's still going to have the $1,000 liability that it has, but now it's going to, maybe if the required reserve ratio is 20%, it's going to keep 20% of that $1,000 as a reserve, and it's going to make a loan of $800. And so that's the bank's asset sheets after asset side after it's made the loan. So it's transformed the asset into a different kind of asset. Instead of the bank holding currency in its vault, it's giving out the $800 as a loan, so that it can now be earning interest on the asset that it has. So that $800, if it gives it out as a loan to someone, they have to repay, and so that's why it's an asset for the bank. So the loans that you make to the bank as a depositor are liabilities for the bank, and the loans that the bank makes to people are assets for the bank. So that $800 that the bank loaned out may be a let's imagine that it's not to a customer of a bank. Typically, the loan is indeed to a customer of the bank, so that person may turn around and deposit the funds in their own bank account. So the bank's liabilities would go up by $800, and its assets would go up by $800 again, in some sense. But it's easier to see conceptually if we think of that person who received the loan as depositing the loan in another bank account. So the bank still has that $800 asset. The person has to pay back the $800, so it's an asset for the bank. But the person has the $800 now, and the person goes and deposits them in a second bank. So if we think of the second bank now, and we look at its assets and liabilities, it gets a deposit of $800, and it would normally then, if it just kept it as cash, have liability of reverse those. Let me erase that. So it has a liability of $800 and assets of $800. So the $800 liability is that the person has deposited $800, so the bank, in effect, owes or promised to make that available whenever the person wants. So the asset side of this bank has gone up by $800. So let's say now it decides that it'd rather not keep that asset in cash, it'd rather lend it out. So it can lend out, so that it also has to have a required reserve ratio of 20%. So it can lend out it keeps its $160 as reserves and lends out $640 That's the loans that it can make that are interest-bearing. It can't lend out, the bank can't lend out the whole $800, right? Because then it would have no reserves. It would have no assets in reserve. So it can't, by current U.S. law, can't lend out the whole $800. Banks, of course, would much rather hold fewer reserves, because reserves, until recently, were not earning interest. Several years ago, the Federal Reserve started to offer interest earnings on reserves. But the bank, of course, would rather have higher earnings and higher interest returns on its loans, and would rather lend out to the private sector than lend to the Federal Reserve. So that's the second bank. Now this $600, we can follow the story again, goes as a loan to someone. The liabilities were still $800 here. This $640 goes out as a loan to someone, and they in turn deposit it into their bank. So now we have a third bank with liabilities and assets, so it gets a deposit of $640, and this $640 could be kept as the asset, but again, this bank is just like every other bank and would rather not keep that as an asset. Instead, we'll keep 20% of it, which, and now we're getting to higher order math, 128, and we'll lend out 512. So these are the reserves, and these are the loans that it makes. So we see that each successive bank gets to lend out, gets a deposit that's smaller than the earlier banks, and gets to lend out a smaller amount. So the initial $1,000 deposit leads to excuse me, a snowball effect, further and further deposits and then loans being made out. But each round, as we think about it, each round is smaller and smaller, and we end up then with a situation where we have our first deposit of $1,000, and then we have our second of 800, and then we have our third of 640, and then we have our fourth of 512, and so on. And the numbers are going to get smaller and smaller and smaller. To find out what the sum of all of these deposits are going to be, remember these are deposits, so when we add them all up, that's the change in the money supply, because remember, the money supply is currency plus deposits. So when we add up all of these deposits, that tells us what the change in the money supply is. So if you think about it, this $800 is 1 minus the required reserve ratio times the deposit, the initial deposit, and this one then is 1 minus the required reserve ratio squared, and so on. So we can rewrite the sum as being the initial deposit of $1,000. The second one is 1 minus required reserve ratio times $1,000. The third is 1 minus the required reserve ratio squared times $1,000, and cubed, and so on. So we have what's called an infinite sum, and they all share this $1,000. So we could take that out, and we have $1,000 times 1 plus 1 minus RR plus 1 minus RR squared plus 1 minus RR cubed, and dot dot dot, right, to the 4th power, to the 5th power, to the 6th power. And it turns out through simple algebra, and if you remember your algebraic long division, that's the same thing as 1 over RR. This infinite series in the limit is 1 over RR, and so this ratio is the multiple of the initial deposit that determines the change in the money supply. So if the required reserve ratio is 0.2, then the 1 over 0.2 is equal to 5. So the infinite series that we had, the sum of we had, would add up to 5,000 would be the total change in the money supply occasioned by this $1,000 initial deposit. Now the real money multiplier is also affected by the public's willingness to hold currency. So instead of depositing all the value in of the loan, some of it is held as currency. Then the banking system can't multiply that, and so the normal, more complex money multiplier is given by a slightly different algebraic formula.